So let us then just begin. So today we are kind of not starting, but like we did one problem last time in this theme of invariance, where the remainders, divisibility and remainders are the sort of obstructions that we will see to something being possible. Okay, so the heading is just simply, remainders as invariance. So this section I'm mostly just taking from mathematical circles, not trying to explore too much. So let's do this. Remainders as invariance. So there was one more theme in one more kind of thing in invariance, which I thought was to prove theorems using invariance, like we had done in pigeonhole principle, but maybe we will not do that. We will do this as the last section and then move to a new topic. Remainders as invariance. So we had done one problem of this last time, and so I'm following mathematical circles. Okay, so let me begin, and then maybe I can ask if you guys have questions from what you have tried. So let's see. Okay, let me try the problems with you guys. So this is problem number 17. Problem number 17. Okay. So let's see the question. So there are two countries A and B. Okay, Delhi and Dahlia, and the units of currency are the dilar and dalar. And in Dila, the exchange rate is $1 for $1. Okay, and here we have 10 for 1. Okay, a businessman has $1 and can travel in both countries exchanging money free of charge. Prove that unless he spends some of his money, he will never have equal amounts of dilars and dollars. Okay, so the words are a little confusing. Okay. So let's see. Yeah, so there are countries. So let's say countries A and B. Countries A and B. Okay, and I'll just say currency A and currency B. Okay. So 10 of currency B is 1 of currency A. Okay, 10 of currency B is 1 of currency A, obviously in country A, right? Because so like in the country, in the country Delia, the exchange rate is $10 for $1. Yeah, so you want $1, so you want one of that country B's thing. Yeah, so 10 of currency B is 1 of currency A in A. Is that right? So you need to give 10, like 10 rupees to get $1, sort of, right? In, let's say, in America, right? So something like that. And similarly, in the country Dahlia, the exchange is $10 for $1. So in Dahlia, it is dollar, and so okay, so that's very strange. $10 for $1. Okay, so 10 of currency A is 1 of currency B in B. Okay, so at least that's what I make of the question. Okay. Right? So am I right? Is that what the exchange rate means? Sorry, I don't know anything about exchange rates. So in Delia, so let me share the screen and you guys can maybe tell me better. So this is something that I've never, yeah. Sorry, is not valid? No, vice versa is not valid because it's no. So what does vice versa mean in this case? Okay, let's just read the question. So vice versa would mean, No, that doesn't make sense because like you understand. So in a certain country, you only can give the other countries money and get this country. So yeah. Anyways, let's see. So let's read this question. Okay. And then tell me what you make of it. Okay. So in the countries Delia and Dalia, the units of currency are dollar and dollar respectively. In Delia, the exchange rate is $10 for $1, right? So you go to the country A and you give 10 of currency of country B in country. We are not. Oh, oh sorry. Oh, sorry. Yeah. Now can you guys see? Yeah. Is it visible? Okay. So try to just read this question and tell me. Okay. Then I will also read. I'm just reading it silently so that you guys can read it. So yeah, is it? So have I interpreted the question correctly? Yeah, it seems Nagesh, does it seem correct? Yeah. So now I've removed it. Okay. All right. So then this is what it is, right? So you have this A and B and 10 of currency B when you take it to country A. Okay. There you get 1 of currency A. Okay. And similarly, you have 10 of currency A. Okay, is 1 of currency B in B. That is what I interpret. If it's wrong, then tell me. Okay. So now it's saying that a business man has so a businessman has 1 of currency A. Oh, so I've not unshared it. Yeah. So businessman has 1 of currency A. Okay. And now he travels to both the countries and just he doesn't, let's say he doesn't spend the money. Okay. He just exchanges. Very strange. He just exchanges the money and then he goes to another country and then again does some exchange and so on, back and forth. Okay. So a businessman. So okay, so he is written here. So so he goes back and forth between countries. Yeah, just exchanging the money. Okay. Okay, exchanging the money. And now we want to show that he can never have equal amounts of both currencies. Okay, so we want to show that he can never have equal amount of both. So without the units, okay, just the equal amounts numerically of both the currencies. Let's just, because it's really confusing for me also because I've never managed to avoid this kind of questions. And so let's say that, so he has 1 of currency A, right? So what can he do in the beginning? So what he does is, so he's in country A. Now what he does is he moves to country B. Okay. And he breaks up his money into X and 1 minus X. So now he So it is that 1 of currency A, he breaks into X of currency A and 1 minus X of currency B. Okay. Now what he does, let's say that this X, he exchanges. Okay, so now both are of currency A. If he, I'm not writing everything, I'm just saying, so he has X of currency A and 1 minus X of currency A. After he does an exchange with X, okay, then what does he get? How much of so how much of currency B can he have if he gives X of currency A in B? X by 10, right? So he has X by 10 of B and 1 minus X of A. Am I right? Yeah, is it right? Okay, so we want to now say that these two are not equal. Let's say, so can these two things be equal? Okay, but then why cannot it be equal? Why can't they be equal? But let's see. So x is 10 minus 10x, and so that is 11x. Okay, so I'm a little confused. So if I take x to be 10 by 11, then it seems correct. Then it becomes equal. This is a mess. Last part of the question, or okay, so what I'm trying to do is, let's say he goes to country B, he has this 1 of currency A, he goes to country B, and he decides to take away X of that currency A and exchange it for currency B. So he gets X by 10 of currency B. Right, because he's in country B, so X of currency A will give him X by 10 of currency B. That's what I'm interpreting, right? But then these two can be equal. Like, why is it not correct to it's a bit confusing, yeah? Or do they mean integers? But then if you want it to be integers, then it does not even make sense. Like, you cannot even do anything in that case, right? Yeah, you cannot do any exchange. Then he needs 10 of currency B to 10 of currency A to even start exchanging anything. So with this one, sorry, so you're saying that in country A itself, with this 1 of currency A, he can get 10 of currency B. That's what you're saying. Yes, 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 yes. Yeah, exactly. Does everybody see that? Is that what you're saying, Nagesh? Ha. Exactly. Yeah, that's what I missed. Correct. I think that makes sense to me. I mean, that is just logical. I think everybody sees. I'm just being stupid. Yeah. So he has 1 of A. So he has 1 of A. So maybe the way I can write it as 1A, right? The 1A becomes 10B. You see? So in country A, 1 of A becomes 10 of B. Okay. So now what can you do? So someone tell us some possibilities that can happen next. So now in country B, 1B can give him 10A. So then let's say that he goes to country B, then he has this 9Bs, and then the 1B, and then he gets 10. From the 1B he gets 10A. So let's say that, so this was in A, this is also in A, but this is in B. Okay. So you see, again, he has the unequal amounts of A's and B's. So what? A's and B's. Yes, yes, absolutely. So if he again stays in B, for example, then he can make it 8B and 20A. If he again stays in B, right? If he decides to go to A, then what can he do? So then he can increase the B's, right? Then you can try to increase the B's. So if then he can become like 19A, or maybe I could just make a column or something, 19A, and from this 1A he can get 10B, so it becomes 18Bs, right? And we want to say that these two can never become equal. I never thought about these things. It looks very strange to me. The money is growing, but I don't know. But anyway, it's just a mathematical thing. Let's see. Yeah. So why is it that they can never become equal? So just think. So you can see that at each stage, one of the numbers is decreasing by 1 and the other number is increasing by 10, right? That is what is happening. You can see, like here, let's say at this stage, the 9 becomes 8, the 9 decreases by 1, but then that means that 1 can be used to create 10 of the other type. So that 10 becomes 20. And you can see that pattern. So one of them decreases by 1 and the other increases by 10. So then why can this never lead to two equal coordinates? Yeah. So for this we really have to think what we had initially. Yeah. So really the question just is just this. You can frame it like this so you can think more clearly here. So initially, let's see. So initially we had 1, 0. Okay. And again, from here, as I said, you can decrease by two, decrease one of them by one and increase the other by zero. So this is the only possibility. Okay, and so on. But in general, if you have x comma y, right, then you can either go to x minus 1 and y plus 10 if we have interpreted the thing correctly, then, or the other way is to increase the x and decrease the y. Okay, is it okay? So you want to say that things can never become equal. In this way, the two coordinates can never become equal. Right? And you're starting from 1 comma 0. Okay? So just think about this. Okay, just think about this. I'll just come in a minute. Yeah, so now the question is like this only. Okay, so one of the as I once said, you want to say that the coordinates cannot become the same if you start from 1 comma 0. Okay, so just think. Okay. Yeah. Hmm. According to the first statement, 10x is equal to y. Um, okay, 10x is equal to y. Okay. No, but is it like that? No, no, no. So what is the x and y? Can you say again? X and y. Okay, so y is number of currency B, right? Or something like. Okay, so x is like x. So when you say x comma y, you mean that he has x of currency A and y of currency B, right? X of A and y. Okay, opposite. Okay, okay, x of B and y of A. Okay, right. Huh. Hmm. Yeah, I mean, if you have x of currency A, x of currency B, then it means that if you have 10, you can do 10x of, no, but it depends on in which country you are in, right? So if you do 10 times of currency B, then you get 1 of currency A. Yeah, but you see, no, but both the things are not simultaneously true. Is that right? That is yeah, that's maybe a good way to say it, right? That what you're trying to say is like maybe this. but both of them are not simultaneously true. Okay, so Pragadish, do you see this? Right? I mean, you cannot do the things at the same time. Both of them are not simultaneously happening at the same time. Right? Depending on which country you are in. So if you are in country A, then you can say that, yeah, I mean, so whatever, right? So if you are in if you are in country A, then you can take x of or rather if you are in if you are in country A, then you can take y of y coins of A and make 10 and get 10 y coins of B. Okay, which is, if you say that is x, but yeah, I mean, you can make that much, yeah, out of y, but both are not simultaneous. So setting up the equation like this is not, it doesn't seem very yeah, very good. Okay. But then so I'm just asking, like, is this formulation okay with everyone, that this is what is happening? Yeah, just make sure that this you understood this. Yeah, Pragadish, Nagesh, what this I'm writing here. Yeah, right. Okay, like you can see, like from the basic 1,0, you can either go here or you can go, well, you can, in the first case you can only go here, but like just one more example I will give. I'm saying that, like with 0,10, what can you do? Well, you can take one of the 10, and you can, you can make 10 of the other, and then you get 9 of the, it becomes 9 of the other, something like that. Or, well, no, here you cannot do anything else. uh, okay, so you're saying like so you're saying x comma y, I've written x minus 1 and this, but, or you can say this one only. So then what will it be? Sorry, say. So from, okay, so this is, it should be y minus 1. I've written it wrong. Yeah. I mean, so you can say that, like, it can become 10y and 0. If that is what you're saying. Exactly. Yeah. Yes. But you see, if I'm trying to capture every step, right, then I'm just writing it like that so that I can capture all possibilities, right? I'm not trying to jump the steps. So obviously from here you can do x plus 20 and y minus 2. Yeah, that is fine, but I'm not going to jump it because then I might miss something. Yeah, so right, that is true. So from here, why is it that we cannot make the two coordinates equal? So now this is just we can remove all this long language.